Welcome to Savi YouTube channel of Sai Vidya Institute of Technology, Bangalore. I am Dr.T.G.Manjunath, HOD, Department of EEE. In this session, let us start a new module, that is two-port networks. Any system or any device, electrical device or electronic system, we require minimum two terminals to apply the input signal, requires minimum two terminals to take out the output. Here I have represented a block box with two terminals here and two terminals here. So any system or a device requires minimum two terminals to apply the input and requires minimum two terminals to take out the output. A pair of terminals at which the signal can enter or leave the terminals is called port. A pair of terminals, we call it as port. If the network or a system is having two pairs of terminals, then it is called two-port network. Since I have taken two pairs of terminals here, hence I can write this as a two-port network. Here, at the input, we have the terminals, we call this as input port. If you consider this as input, we have a pair of terminals, we call this as input port. Again, if you are taking the output signal at this pair of terminal, we call this as output port. Output port. So, in fact, many devices like amplifiers, rectifiers, transformers, transmission lines, etc. falls under this category. Why we need to study this two-port network? What is the advantage of representing a network or a system with the two pairs of terminals? Now, before going to that, here what we are going to consider in two-port network is, at the input we represent and we take the variables, current and voltage variables like this. We consider the voltage as V1 at the input with the polarity shown, and we take voltage at the output as V2 with the polarity shown. And we take the current at the input port as I1 with the direction shown, and we take the current at output as I2 with the direction shown. Even though at the output current leaves, when you are defining a two-port network, we assume current entering into the network. This is how a two-port network is defined. Now, what is the use of representing a two-port network with two pairs of terminals and with four variables, with two current variables and two voltage variables? So, it is possible to find many parameters for the given network. What parameters you can find? You can find impedance parameters, means you can find input impedance for the system or a network, you can find the output impedance, you can find that is called Z parameters, you can find Z parameters, means impedance parameters, we can find admittance parameters, that is input admittance, output admittance, transfer admittance, you can find for the given network. Then we can find H parameters, means hybrid parameters. Hybrid parameters means you can find a gain, current gain, voltage gain, even in that the reverse voltage gain or the current gain. Those parameters you can find in H parameters. You can find the T parameters, we call it as transmission parameters. So, all these parameters we can find for the two-port network just by representing a network by a block box with two pairs of terminals and with 4 variables. Just by playing with the 4 variables I1, I2, V1, V2, it is possible to find all these parameters for the given network. That is the advantage of studying this two-port network. Now, what we are going to do in this session or in this module is, first we are going to obtain Z parameters, Y parameters, H parameters and T parameters for the given two-port network, and we are going to obtain the relationship between these parameters. After discussing those things, we are going to solve the problems on this two-port network to find these parameters. Now, here these for Z, Y, H and T defining equations are there. So, that defining equations, first we have to understand what is the defining equation of Z parameters, Y parameter, H parameter and T parameters. Once you know the defining equations of those parameters, then we are going to obtain the relationship and also we are going to define these parameters now. Now, to write the defining equations of Z, Y, H and T parameters, we are going to consider 2 variables as independent variables and remaining 2 as dependent variables. So, out of 4 variables V1, V2, I1 and I2, we are going to consider 2 as independent variables and remaining as dependent variables. Depending on which variables you are considering as independent and dependent, it is possible to describe the following parameters. So, parameters are Z parameters, Y parameters, H parameters and T parameters. These T parameters also known as ABCD parameters. So, in Z parameters, dependent variables are V1 and V2. So, voltages are considered as dependent variables, remaining is what? I1, I2 are considered as independent variables. For Y parameters, means admittance parameters, opposite you should write. So, I1 and I2 are depending on V1 and V2. Okay. For H parameters, the dependent variables are V1 and I2, and what are the remaining? If V1 and I2, remaining is I1, V2. I1, V2 are independent variables. Next, for T parameters, means for ABCD parameters, the dependent variables are V1 and I1 and it is depending on V2, I2. So, if you know this just a small table, it is very easy to write the defining equations of these parameters. Without knowing the defining equations, we cannot derive any expression here, we cannot find any relationship, we cannot solve any problem in this model. Hence, if you know just this small table, it is very easy to write the defining equations. Now, I will show you how to write the defining equations for these parameters. All of you observe here. Now, so dependent variables for Z. So, what is the defining equations I am showing here? Defining equations. Defining equations of Z parameters. So, defining equations of Z parameters. So, here you have two equations, one is voltage equation, another is also voltage equation. V1 is depending on I1, I2, this is the meaning of this. So, V1 and V2 are dependent variables. No, V1 is depending on I1, I2, V2 is also depending on I1, I2. Here in Y parameters, I1 and I2 are depending on V1, V2, means I1 is depending on V1, V2, I2 is also depending on V1, V2. Similarly, in H parameters, V1 is depending on I1, V2, I2 is also depending on I1, V2, like that. Similarly for this. Now, I will show you just for your reference I will show you how to write the equation, defining equations of Z parameters. Two equations you should write. Both are voltage equations. So V1 is equal to, so you know V is equal to I into Z. Okay, I is here. You should write here the coefficient as Z for this. So V1 is equal to Z11 I1 plus Z12 I2. You can see here first equation for V1 is equal to coefficient you should write Z here because V is equal to I into Z. Okay, I is here. So coefficients you write Z and we are adding both because V1 is depending on both I1 I2. So V1 is depending on I1 I2, coefficients you write Z. So when writing Z here, I am considering the parameters of Z parameters as Z11, Z12, Z21, Z22 like that. So another equation you can write, V2 is equal to what? Same. V2 is also depending on I1 I2, means I1 I2 remains same. Here coefficients becomes Z21 I1 plus Z22 I2. So I1 I2 is same, and only thing is coefficients you are changing. So V1 is equal to Z11 I1 plus Z12 I2. Similarly, V2 is equal to Z21 I1 plus Z22 I2. So this is what defining equations of Z parameters. Suppose if you want to write defining equations of Y parameters, what I should write? For example, for Y parameters, defining equations are, so what are the equations? Current equations. So left side I1 is equal to I1 is depending on V1 V2 here, means left side I1 I2 comes, wherever I1 is there you should write V, but coefficient what I should write? I should write Y because I am finding Y parameters, because you know that V is equal to I into Z, I is equal to V by Z now, because I am finding I here, I am writing the equation for I, that is equal to 1 by Z is what? Y. 1 by Z is what? Y. Write V as it is. So I is equal to Y into V. I is equal to Y into V. So I is equal to Y into V, means coefficients was what you should write? You should write Y here. Here also Y. So I1 is equal to Y11 V1 plus Y12 V2. You can see here. I1 is depending on V1 V2. I1 is depending on V1 V2. Coefficients you should write Y here because I is equal to Y into V. Similarly, I2 equation we should write. So Y21 V1 plus Y22 V2. So defining equations of Y parameters. Suppose if you want to write defining equations of H parameters, what you should write? So V1 is depending on I1 V2, I2 is depending on I1 V2. Coefficients what should write? H, H11, H12, H21, H22 like that. So H parameters, suppose if you want to write defining equations for H parameters, so you have to write two equations. One is V1 equation, another is I2 equation now. So V1 is equal to what? H11 I1 plus H12 V2, because V1 is depending on I1 V2. V1 is depending on I1 V2. Similarly, I2 equation, same. I2 equation H21 into I1, that remains same. H22 V2. So this is how to write defining equations of H parameters. Last one, very important, defining equations of T parameters, means ABCD parameters. Here we are not going to represent as the coefficients as T11, T12, T21, T22 like that. Instead of that, we use ABCD. So just directly I will show you the defining equations of ABCD parameters. So what are the equations I should write? V1, I1 now. So V1, I1. Two equations I should write. So here V1 depending on V2, I2, I1 depending on V2, I2. So here very important is we are going to use the coefficients as ABCD. Now here A, V2 first variable minus all parameters you are taking plus, only for this you should take minus. This is how it is defined. I am not defining, it is defined. So, AV2 minus BI2, BI2. Similarly, I1 is equal to CV2 minus DI2, CV2 minus DI2. See, these equations, either you have to remember, you have to memorize, or remember this small table to write the equations. That is left to you. Because I am just following like this. If you know this table, without any confusion, you can write the equations. Or you forget about the table, remember the equations. So, defining equations of Z parameters, defining equations of Y parameters, defining equations of H parameters, defining equations of T parameters. All these 4 equations, total 8 equations you must remember to understand this model. Okay. Now, we are going to define one by one, that is parameters. First Z parameters Y, H and T we are going to define. Let us see what is the meaning of defining those parameters. Defining means, what is Z11 meaning? What is Z12? What is Z21? What is Z22? What are those? Because we don't know, just we have taken Z11, Z22, Z12 like that, just we have taken the coefficients. But what that represents, that's what we are going to define one by one now in further session. Okay. To conclude this session, the defining equations of Z parameters are voltage equations. V1 equal to Z11 I1 plus Z12 I2, V2 is equal to Z21 I1 plus Z22 I2. Defining equations of Y parameters are current equations. I1 is equal to Y11 V1 plus Y12 V2, I2 is equal to Y21 V1 plus Y22 V2. Opposite to this, wherever V is there, write I, wherever I is there, write V, wherever Z is there, write Y. That's all, opposite. Next, coming to the defining equations of H parameters, one is voltage equation, other is current equation. You should not change the variables, very important. V1 is equal to H11 I1 plus H12 V2. First 1, next 2, 1, 2. You can see wherever you want. 1, 2, 1, 2, 1, 2, 1, 2. Like that only should come. So, H11 I1 plus H12 V2. I2 is equal to H21 I1 plus H22 V2. One is voltage equation, other is current equation. So, this is what defining equations of H parameters. Defining equations of T parameters, also known as ABCD parameters. Again, one voltage, other is current equation. So, AV2 minus BI2. We are not using T11, T12 like that. Instead of that, you are using ABCD as coefficients. Very important is you should use negative sign. So, AV2 minus BI2, I1 equal to CV2 minus DI2. Both are 2 here, no 1, 2, both are 2. So, but first is voltage, other is current. Like that, somehow you have to memorize these equations to understand the further sessions. Okay. Now, in the next sessions, let us see how to define or how to find Z parameters, Y parameters, H parameters and T parameters. Okay.